Now, when we do a standard neuropsychological evaluation, there are a number of different areas of cognition that we'll routinely assess. So we'll usually look at a person's general intellectual ability. And in a minute, I'm going to contrast more crystallized and fluid abilities. And it's those crystallized abilities that we learn over time from our education that we actually look at as kind of hold tests, that we don't expect people to show a lot of changes in over time or with insult to the brain. We'll also look at their processing speed, their ability to attend to information, their memory, their language, their visual, spatial, and visual motor abilities, and kind of the higher order executive skills, so their problem solving and reasoning. And what we're going to do is we're going to take a look at each of these areas, and we're going to look at the changes that occur as a result of the normal aging process, and then we're going to talk about how we might need to think about those sort of changes when we're developing these different technologies for our aging population. Okay, so this is a chart that contrasts those crystallized sort of abilities with fluid abilities. So crystallized abilities, some examples are things like vocabulary test. So if I gave you a word and I asked you to tell me its meaning, or I gave you a word and I said, which of these 4 words matches this meaning? Or if I gave you 2 things like apple and banana and I said, how are they alike? Okay, so those are things that draw on information that we've learned over time. And those are the types of abilities that we don't see much change in as we age. And in fact, in most of our studies, and you can see that here, our 16 to 17-year-olds and our 20 to 24-year-olds aren't performing as well as our older adults. Now, there's other skills that we call fluid that are more kind of novel, problem-solving type skills, as well as kind of basic abilities like working memory and processing speed that may not necessarily they'll get better with practice, but not when you give a novel task that a person's never seen before. And those, you can see, have a downward trajectory in terms of the aging process. And here's an example from some of our own work. So this is a type of vocabulary test, provoke, and then the person has to provide the definition, for example. And these are actually, I think I took this like as an example from the Shipley. So this is an example of the 50th percentile. If you're in the 20 to 24-year-old range, then you're going to be getting about 34 to 38 correct to be average or 50th percentile. And you can see that 65 to 69, it goes up a little bit. Now you need 39 to 43 to be at the 50th percentile. And at 85 to 89, you're 33 to 37, which is exactly the same as where our 20-year-olds are, right? So this is the type of test that doesn't show a lot of changes with the aging process. Now let's contrast this with a fluid test that's more an abstract reasoning test. And this still, I don't know, this still blows my mind. Like every time I see this, I'm like, why is this? Why does this happen? But okay, a test like this, a 20 to 24-year-old is going to need 16 to 17 correct to be at the 50th percentile. A 65 to 69-year-old is only going to need 10 to 11 correct. By the time you get to 85 to 89, you're only going to need 7 correct to be at the 50th percentile. And if you can score the same as a 20-year-old is, you're in the superior range. You're at the 97th percentile. So there is a real change in our ability to do these types of fluid reasoning tests that we do not see in these crystallized abilities that we learn over time that are less novel. Any questions about that? Okay. All right, so let's look at processing speed now. Processing speed is one of those things where we're fastest in our 20s, and then it starts to decline over time. There are a number of different ways that we can look at processing speed, and experimentally, a lot of them have used these simple and choice reaction time tasks. So you can put a person in front of a computer, for example, you can have a light go on and they have to press a key as soon as the light goes on. So we can separate out their processing of, okay, I'm registering the light from the actual motor time by just having them take their hand off the key and then move it. So the detection itself will be that time that they actually lift their hand, and then it's the movement time. So we know that older adults are slower in detecting those stimuli. The other thing, when we give them two stimuli, so we can make it more difficult, we can have a green and a blue light, and we can have two response keys. And when the green one goes on, they have to press one, and when the blue one, they have to press the blue response key. So that increases the amount of information. Now they not only have to detect the stimulus, but they have to make a choice. They have to determine which one it is. And what we see is that as the number of decisions increase, the task complexity increases the difficulty of the task for the older adults. So they have even more difficulty with processing speed. They get even slower when there's more decisions that need to be made. Now, the way that we can look at this in some of our tests, and this is an example of something that you might see in a WACE or in our symbol digit modalities test, is you ask people to quickly go across the line and to fill in the number that goes with the key up there. And I put in here data from the 50th percentile for these different age ranges, and we give them 90 seconds to do as many of these as they can. So there's more going down the page. And you can see that at age 20 to 24, you have to fill out, or the mean number that these younger adults fill out is 70 to 82 of these boxes. By 60 to 69, you're filling out 52 to 56 of these boxes to be scoring at the 50th percentile. And then look what happens by the time you're age 85 to 89. You only need to be filling out 33 to 37. So you can see that significant change in the speed with which we're doing information, being able to register this information. And you can see that if you're performing at the age of a 20-year-old, you're in the very superior range, greater than the 99th percentile. One of the things that sometimes happens with my students in the lab is that they get a lot of experience early on working with older adults, and you can tell me if this is true for any of you. And so they may get used to the fact that their older adults are performing at about this speed on the digit cancellation test. And then they go and they test someone that's younger who's had a traumatic brain injury, and they perform a little bit better, and they think that they're doing really well, but they haven't had enough experience with kind of a normal younger adult to kind of see those differences, because there really are these dramatic differences in the speed with which information processing changes as we get older. Now, there's been a lot of questions about why does this happen? You know, why do we see such a dramatic change in that kind of rate of speeded processing? This is one example. This is an information loss model that uses the idea that we process information in stages serially. So we have to register it, and then we have to encode it, and then we make a decision, and then we make an answer. So the idea here is that at each stage, the older adult loses or has less pure information. So if you think about a copier, if you copy something and then you have that copy and then you copy that again and then you copy that copy, you lose information each time. And so the idea is that older adults are losing more of that information, so it takes longer for them to be able to complete the task. Another sort of neural network idea is that, you know, when we go from stimulus to response, we want to use the least amount of neurons that we can. But as we get older, some of these neurons are going to die, and we're going to have to make new connections, and those new connections then take longer to get from stimulus to response, and therefore it's going to take us longer to process that information. Now, even though we see those changes in speeded processing, there are ways that older adults can compensate. So things like different strategies that they use, practice Although practice may not get you to the same level as a younger adult if a younger adult practices too. So there have been studies where they've brought older and younger adults in and had them do these reaction time tasks for thousands and thousands of trials to see if older adults could improve to the level of younger adults. And older adults do improve, but younger adults also improve. And I think that's one of the things to think about in terms of some of these brain games that are out there, that if people do the task enough, they are going to get better, right? And that can have a lot of great motivating effects and may also have some effects on cognition. But some of that is also the practice. If you practice things, you will get better at them. Experience is also important too. So for example, think about driving. So reaction time is very important in driving. And if we say reaction time is fastest in your 20s, why is it that our best race car drivers aren't in their 20s? Any ideas? It's probably experience, right? So an experienced race car driver knows how to kind of stay out of situations that might be precarious or get them into trouble. So these different strategies and experience are things that older adults can apply to help with some of these changes in speed of processing. And I always like to think about it like this. You can still do it, it's just going to take you a little bit longer to do it. So in terms of these age-related speed of processing changes, what sort of implications do you think they have for any sort of technology development that you're going to be doing? Or that might be done with older adults? Okay, so definitely one of the things that we had done in some of our early work, those videos that we recorded, the initial information, they made it appeal to a younger adult, and they had so many things happening so quickly that it was overwhelming. So if you design something for older adults where there's so many things that are happening at one time, that's probably not going to be something that's going to be good ease of use for them, right? Okay, very good.